Ever wonder how AI learns to truly understand images, charts, and data, not just memorize them? Let's pull back the curtain on a groundbreaking process that turns messy information into clear, reliable answers. Think of it like giving a robot a masterclass in critical thinking, step by step, with precision, practice, and a lot of digital elbow grease. Imagine teaching a robot to interpret a chart showing work hours across age groups. It might say, the 1821 group works 4 hours, and the 2229 group works 3.2 hours, so the difference is 0.8. But how do we ensure the robot actually grasps the logic behind that calculation? That's where visual grounded reasoning, VGR, comes in. VGR is the secret sauce that teaches AI to look at the data, not just guess from text. Traditional models might rely on patterns in words alone, but VGR forces them to analyze visual elements, like identifying specific bars in a graph or numbers in a table. It's like training a detective to use a magnifying glass, not just read a report. Here's how it works. When a model encounters a question, it doesn't just spit out an answer. It scans the image, isolates key regions like the 1821 bar, and integrates those details into its reasoning. This process is powered by a massive dataset called VGR-SFT, a treasure trove of image-text pairs that teach AI to connect words with visuals. Unlike older methods that rely on rigid rules, VGR lets the model choose what's important, mimicking how humans focus on labels or numbers when solving a problem. And here's the breakthrough. VGR doesn't need to process every pixel. By zeroing in on critical regions, it uses 30% fewer image details, but still outperforms traditional models. On benchmarks like ChartQA and AI2D, it scores up to 12.9 points higher, like getting better results with a lighter workload. But how do we teach the AI to find those key regions? The answer lies in a rigorous training process. Researchers used reject sampling. If the model answered incorrectly, like claiming Raphael Nadal won the French Open 13 times, when the chart says 12, that data was discarded. It's like proofreading a draft to fix errors before publishing. Then came data rewriting. If the model wrote, the blue bar is taller, they'd refine it to, the 1821 male group works 4 hours, while the 2229 group works 3.2 hours. It's like polishing a rough draft until the key details shine. No ambiguity, just clarity. The training unfolded in 2 stages. First, cold start data, basic examples like math problems to build a foundation. Then, real-world complexity using the Open-R1 dataset, which mimics human reasoning. It's like teaching a kid to add with blocks, then moving to word problems. But what if the model got stuck? That's where visual grounding kicked in. If a question referenced green bars in a chart, the model would point to the exact data, saying, look here, 2016 is 29%, 2015 is 23%, so the difference is 6%. It's like giving the AI a magnifying glass to focus on the right details. The result? A model that doesn't just guess, it understands. Whether analyzing medical scans, decoding graphs, or noticing a kayaker's calm posture means the mood is neutral. This AI thinks like a human. So next time you see an AI answering a tricky question, remember, it's the product of careful editing, smart training, and a ton of digital elbow grease. The future isn't just about machines that talk. It's about machines that see, understand, and reason. Stay curious, and let's keep exploring how these models tackle even bigger challenges.